Let's have our lecture video in integral calculus, this time with the second integration technique, integration by algebraic substitution. The substitution method, also called u-substitution, is used when an integral contains some function and its derivative. In this case, we can set u equal to the function and rewrite the integral in terms of the new variable u. This makes the integral easier to solve. Let's try to solve these examples using this principle. Okay, for number 1, we have the integral of square root of x dx all over 1 plus x. Now it says there we will let u, there. You can set u equal to the function and then rewrite the integral in terms of the new variable u. So we will let u here equals, I will choose the more complicated one to substitute with u. So I will choose square root of x. So this is u squared is equal to x. And then we have 2u du is equal to dx. Then we substitute those values in terms of u. So we have here the square root of x is equal to u. So we have here becomes u. The dx becomes 2u du. Then 1 plus the x here is u squared. So it becomes 1 plus u squared. So this is equal to, let's bring out 2 here, square root of u squared du all over 1 plus, or that is, let's put here u squared plus 1. Now since these two has the same exponent, we can divide it. So let's have u squared here divided by u squared plus 1. So let's put here 1. 1 times u squared is u squared plus 1 times 1 is 1. It becomes minus negative 1. So the answer is 1 minus 1 over u squared plus 1. Then, right here, 2 square root, integral of 1 minus 1 over u squared plus 1. Don't forget the u. Then distribute. So let's distribute here. This becomes 2 integral of du minus 2 integral of du over u squared plus 1. And this becomes 2u minus, this is actually inverse function. So 2, for inverse we have 1 over a. The a here is 1. So if you watch the previous video, I have already discussed inverse trigonometric function. So arctan u over a is 1. Then plus c. So this is equal to 2u minus 2 arctan u plus c. Now this is not the final answer. Remember that we substituted u for x, or u for the square root of x. So let's bring it back. Let's substitute in the reverse manner. So u is square root of x. So it becomes 2 square root of x minus 2 arctan of u, which is the square root of x, plus c. This is the final answer. If your answer is this one here, then that is wrong, because the the problem here is in terms of x, not in terms of u. So if your answer is this one here, then I'm sorry, I will mark it as wrong. This is the correct answer. Okay, that is for example number 1. So screenshot it first. Now let's go to sample number 2. We have here integral of square root of x squared minus a squared all over x dx. So we have here a as a constant. Then again, I will let u here as the more complicated one, which is the square root of x squared minus a squared. So it becomes u squared is equal to x squared minus a squared. This is x squared is equal to u squared plus a squared. Then x now is equal to square root of, or let's say that is u squared plus a squared raised to 1/2. Then since we were able to have value of square root of x squared minus a squared, we have x. How about dx? We will find dx here in this portion. This is 2x dx is equal to 2u du. Dx is equal to 2u du all over 2x, cancel 2. So what's left is u over x. Dx is equal to u du all over what is x? X is u squared plus a squared raised to 1/2. Okay, so that is for the u. For the x. Then substitute the original equation. So we have here for the square root of x squared minus a squared, we have there u over x is u squared plus a squared raised to 1/2. Then for the dx, we have u du all over u squared plus a squared raised to 1/2. Then we now have u squared du. How about this portion here? The base are the same. The exponent 1/2, 1/2. So 1/2 plus 1/2 is 1. So the answer here is u squared plus a squared. Then we can divide that already. Same exponent. So we have here u squared divided by u squared plus a squared. That's 1 here. 1 times u squared plus a squared. Negative, negative. So this is negative a squared. I put here negative sign, that is inverse of the sign here. Then we have there minus a squared all over u squared plus a squared. Okay, then let's go back to the original equation and to the solution. 1 minus a squared all over u squared plus a squared du. Distribute. We have integral of du minus a squared du all over u squared plus a squared. Now this is now equal to u minus a squared. This is already inverse triangle. So 1 over a arctan u over a plus c. This is equal to u minus a arctan u over a plus c. Now, that's not yet the final answer because the original equation is in terms of x. So we will substitute again. So we have the value for u is x squared minus square root of x squared minus a squared. So u is square root of x squared minus a squared minus a arctan of square root of x squared minus a squared all over a plus c. So this is the final answer for number 2. Screenshot first. Let's go to number 3. Sample number 3. We have here the integral of square root of x raised to 3 minus 1 over x dx. Again, that's let u, the more complicated one, the square root of x raised to 3 minus 1. U squared is equal to x raised to 3 minus 1. X raised to 3 is equal to u squared plus 1. X is equal to u squared plus 1 raised to 1/3. Then for the dx, you can find it here. For 3x squared dx is equal to 2u du. Then we have here dx is equal to 2u du all over 3x squared. And dx is now equal to 2u du all over, the value for x is u squared plus 1 raised to 1/3. Substitute all values. That is equal to integral of u over x. The x here is u squared plus 1 raised to 1/3. Then the x is 2u du all over u squared plus 1 raised to 1/3. Or no, it's not 1/3, it's 2/3. Why? Because 3x squared. Here it's 2/3. Okay. And that's why I encourage you to have a more cleaner solution sheet so as to see these kinds of mistake. Now we have here equal to 2/3 of because there's 3 here. Forgot. It should be 3. 2/3 square integral of u squared du all over, we have here same base. Then we have the exponent 1/3 plus 2/3, so that is equal to 3 over 3, 1. So we have here u squared plus 1. Okay, so we can divide it again since they are equal in exponent. And divide that, u squared they're divided by u squared plus 1, u squared plus 1, negative sign, then positive becomes negative sign, minus 1 over u squared plus 1. So this becomes 2/3 of 1 minus 1 over u squared plus 1 du. Distribute, we have here 2/3 of du minus integral of du all over u squared plus 1. So 2/3 du over u squared plus 1. Again, this one here is inverse. So we have here 2/3 u minus 2/3 1 over a arc tangent of u over a plus c. So that is 2/3 u minus 2/3 arctan u plus c. That's not yet the final answer. Second substitution, wherein u is square root of x raised to 3 minus 1. So we have here 2/3 square root of x3 minus 1 minus 2/3 arctan square root of x raised to 3 minus 1 plus c. So that is the answer for number 3. Okay, screenshot first. Let's go to the last example, the number 4. Now, this number 4 can have, actually, they can have more than one solution, but they always arrive at the same answer if you've done it properly. So, let's show here the solution number 1. For solution number 1, I will let u here as the more complicated x squared plus a squared raised to 3. So it becomes u raised to 1/3 is equal to x squared plus a squared. Then x squared is equal to u raised to 1/3 plus, oh no, it's minus. So it is minus a squared. X now is equal to u raised to 1/3 minus a squared raised to 1/2. So we can have the dx here, this part. This is 2x dx is equal to 1/3 u. So what is 1/3 minus 1? It's negative 2/3 du. So dx is equal to u raised to negative 2/3 du all over 2 times 3 is 6. So we have there 6x. And then x is u raised to 1/3 minus a squared raised to 1/2. So that's for dx. Let's substitute all values here to the original equation. So we have here equal to integral of x raised to 3. For x raised to 3, we have here the value of x, u raised to 1/3 minus a squared 3 times 1/2. So that is 3 halves. Over this one here is u. Then we have the dx. dx is u raised to negative 2/3 du and over 6 times u raised to, or 1/3 minus a squared 1/2. Okay. So this is now equal to 1/6 integral of, okay, let's see, you can cancel off here this portion here. They have the same base. So look at it closely. They have the same base. What will happen? If we put it in the numerator, it becomes negative 1/2. So we have here 3/2 minus 1/2. It's 2 over 2 is equal to 1. Therefore, what we will put here is u raised to 1/3 minus a squared raised to 1. How about the u? If I put u here in the numerator, it becomes u raised to negative 1. Then we have here minus 2/3. So we have there 2/3. So negative 1 becomes negative 3 over 3 minus 2/3. So that is equal to negative 5 over 3. So we have here u raised to negative 5 over 3 du. This is equal to 1 over 6 integral of, distribute. What is 1/3 minus 5 over 3? That is u raised to negative 4/3 du minus a squared over 6 integral of u raised to negative 5 over 3 du. So we can have power formula here. 1 over 6 u raised to negative 4/3 plus 1. Negative 4/3 plus 1 is negative 1/3. Then whatever happens to the exponent will happen here in the denominator. Minus a squared over 6 u raised to, what is negative 5 over 3 minus or plus 1. Negative 5 over 3 plus 1, so that becomes negative 2/3 all over negative 2/3 plus c. Don't forget plus c. So this becomes negative 1/3. So it becomes negative u raised to negative 1/3 all over 2 plus, so this becomes 2/3. So 3 over 2 cancel out. What's left is, so positive 1/4 a squared u raised to negative 2/3 plus c. Okay, so I think we covered that. Then substitute from the original variable. So for substitution for u here is x squared plus a squared raised to the power of 3. Okay, so what happens here? If we substituted it, it becomes negative x squared plus a squared raised to negative 1/3 times 3 over, this actually becomes negative 1. Negative 1 oh, it's negative 2. Oh, it's 2. Sorry. Negative, this becomes negative 1. Plus 1/4 a squared, then becomes x squared plus a squared becomes, what is negative 3? Multiply this with 3, negative 2. Right? It's negative 2 plus c. That is equal to, so negative, since this becomes negative 1, so this becomes 1 all over 2 times x squared plus a squared plus, this becomes a squared all over 4 times x squared plus a squared squared plus c. That is for this first solution. And it's kind of complicated because of the presence of the fractional exponent. That's the first solution. Now how about for the second solution? So let's use that one. For the second solution, let's say write it x raised to 3 dx all over x squared plus a squared raised to 3. I will let u is equal to, what we mentioned a while ago is the more complicated one. So what if I put u here as the x squared plus a squared in that equation? So let's see. What we have here is x squared is equal to u minus a squared. So there's no square for u there. Then we have here x is equal to u minus a squared raised to 1/2. Then for dx, we will take this one. For dx, we have 2x dx is equal to we have there du. So dx is equal to du over 2x. So dx is equal to du all over u minus a raised to 1/2. 2. Again, I forgot again the 2 there. So it's 2 times u minus a raised to 1/2. Okay, let's check. So again, I forgot the 2 in this portion. Okay. Substitute. Then we have for x here, it's u. It's u minus a squared 3/2. Then this portion here will become u raised to 3. Then for the dx, we have here for the dx du all over 2 times u minus a squared 1/2. Okay. So again, you can see here, exponent, same base. So what happens? 3 over 2 is positive, negative 1/2. So it becomes 2 over 2. So that is equal to 1. So this is now 1/2 integral of let's say u minus a squared du over, okay, so u raised to 3. Distribute, we have here 1/2 integral of u du all over u raised to 3 minus constant a squared over 2 integral of du over u over 3. Then we have here 1/2 integral of cancel, so what's left for me is 2 negative 2 d minus a squared over 2 integral of u negative 3 du. So this is now equal to 1/2 u raised to negative 2 plus 1 is negative 1 over negative 1 minus a squared over 2 negative 3 plus 1 is negative u raised to it's u raised to negative 2 all over negative 2 plus c. So the final answer is negative 1 over 2u plus a squared over 4u squared plus c. Then that's not the final answer. Let's substitute again to these values here, especially the u. What's the u again? U is x squared plus a. Substitute, so it's equal to negative 1 over 2 times x squared plus a squared over 4 times x squared plus a squared plus c. Okay, so we can have this already as an answer. So that's for the second solution. Is the answers the same? Are the answers the same? 1 over negative 1 over 2 times x squared plus a squared. So negative 1 over 2 times x squared plus a squared. So screenshot the solution. They are the same. So whichever solution you use, if it is done properly, then you will get the same results.